We are building a multi-agent AI system that functions like a real software team with specialized agents for product analysis, execution, and research. By the end of this video, you will understand the entire blueprint and you will get access to the GitHub repository to build your own version. Now, we started from LLM, just LLM with prompt, and then we moved it to LLM with RAG, or Retrieval Augmented Generation, in which we have something like vector database and we are retrieving data from. And then we moved it to the third stage, which is about LLM, RAG plus tools, something like executing a specific task. We moved it to LLM, RAG, and tools, but with reasoning capabilities. And now we are in multi-agent system stage, in which we have team of agents that can collaborate and can execute or finalize a specific tasks together. Now, this system is literally unlimited because you can break down any task in a smaller task and then create an agent for a specific task and then define the communication protocol between these agents. For that reason, we are believing that multi-agent approach is going to be the future. Now we have two scenarios: break into more focused agents or use connected agents. And every scenario or every case is completely different. Now, if you have like a single developer or a small team of management entire agent solution, in this case, you can break down into more focused agents. And even if you want logical group tools, I believe MCP is the best approach to connect different AI agents together in order to collaborate in doing specific tasks. So this is the abstract of MCP approach. We have the client and the server, and every one has its own tools, resources, and the prompts. So this is the communication pattern, or this is the communication protocol between the two entities or the two parties. And those are the three main components of any MCP in the world. Now, as I mentioned, the way AI agents or different tools in the MCP communicating is very important because the user will just send a message or a request in plain English. And we need to have something that can map and manage the way we are triggering and the way we are organizing the workflow. And for that reason, we have something called the planner agent or the orchestrator, in which this agent or this tool is taking the full responsibility of managing the communication and planning how to execute specific tasks. So orchestrator is the core engine of any MCP or any multi-agent system. So now, to break down the needed capabilities or the required capabilities, we have four main capabilities. And the first one is the discovery. So for example, agents must advertise their capabilities so clients know when and how to utilize them for specific tasks. And we've talked about this topic before when I said that we need to define our tools or agents in a good way. So when you send your plain English or when you send your request to the MCP or the orchestrator to get something done, this planner that you are talking to can trigger the appropriate tools based on their description. And for that reason, we need to define agents and tools in professional and comprehensive way. So the planner or the orchestrator can trigger the right tool and the right time. And the second one is user experience navigation. Now, clients and agents need to agree on communication method like text, forms, iframe, or whatever. The very basic form of this communication is just text. Now, the third one is task state management. Now, clients and agents need like a mechanism to communicate the task status, changes, and all the rest of the variables. So eventually they can collaborate in doing something. We just have two ways to connect different agents or two ways to build a multi-agent system. The first one, and my favorite, is the MCP or Model Context Protocol, and the second one is the A2A or Agent-to-Agent Protocol from Google. And the reason why I prefer to use MCP is that it is very scalable and it can literally solve 99% of the use cases that we are facing every day because it is tool-based approach. Now, in MCP, and as we are going to see in the code, in the Python code, it is tool-based communication in which we have tools and we have a way to trigger these tools in a professional manner. So you connect agent to tool, APIs, resources, with structured input and output, which is JSON. And we have ADK or Agent Development Kit for enabling wide range of MCP servers to be connected with other languages and other frameworks, like, for example, LangChain, LangGraph, and all the rest of these agentic frameworks. Now, the second one is the A2A or agent to agent, and it is agent-based collaboration, in which we have specific agents specialized in something, and they are collaborating to get something done. So it is dynamic, multimodal, and open standard protocol, and it also has the ADK for most of the agentic AI framework. So literally, I built an AI engineering team or a complete software company. And these are the tools that I've been working on. So first, we have the user connected to a fast API server, or he can connect it directly to the MCP server port. And I'll show you the two ways. And this user is talking to the orchestrator that is able to plan and break down the tasks for every single agent, or in our case, for every single tool. And basically, we are using Gemini for language, or Gemini as the main LLM for doing all these tasks. And after the user pass the message or the request to the orchestrator to build a specific app, we first pass this message to product analyst that is able to analyze the whole message and then extract all the requirements and the user functional requirements. And then this is the protocol, or this is the communication protocol. And this is actually a sequential protocol. We are passing the messages from every single tool to the next tool. So basically, every single one has its own capabilities. So for example, research engineer has access to Tivoli web search. So it is just for researching and finding similar topics to find the best practices. And then we pass the message to the software architect. And this is just for system design and technology stacks, which framework to use or which language to use based on the output from research engineer. And then we pass to technical lead for implementing and planning the task breakdown. And then we have the senior developer for the actual product implementation. And eventually we have the last stage, which is about testing and DevOps engineering, and finally the document specialist in order to document the whole project. And finally, you will get the generated project folder that covers all the things that you wish. So it is literally a software company. The user just need to pass the prompt that covers what the user wants. You can just scale this system to so many other use cases in which you have different tools collaborating and talking to each other in a very professional way. And this is just an example about how strong MCP is. Now, we are using Gemini as the main LLM for the agents and tools, and we are using Tivoli for searching and for browsing about the best practices for research engineer. And this is the first tool, which is the product analyst, and it takes user requests and additional context. And this is just a string or text that the orchestrator passes to product analyst. And this is the prompt of this tool. Product analyst analyze user requirements and creates detailed product specification. So this agent understands user needs and business goals, create user stories and acceptance criteria, identifies core features and MVP scope or the minimal viable product, defines success matrices, and this is the arguments or the parameters. We have the user request, user's application idea or requirements, and additional context, which is any additional context or constraints. And basically, the orchestrator is handling all these parameters. And this is the return, detailed product analyst and requirements document. So after you pass your plain English to the orchestrator, first one is the product analyst to receive your request or your project specifications, and then it will work on this human language to turn it into software requirements. So basically, this is the user request, as we are passing this as dynamic field to this prompt, and those are the steps to take. You will have this project and you will have the prompt of editing and playing around with this server. So just feel free to add and eliminate members. Sorry for interrupting. If you just found this video helpful, consider subscribing and like this video. Now let's run this first. So now it's running in port 8000. So now we are gonna open this inspector from this file. This is the command to open this inspector in order to see all the tools that we have. So let's run this instruction and it will give you this session token. And to open the inspector, all you need is just to go to open inspector with token, which is this link, and there we go. First you need to select streamable HTTP, and then in this URL add the port that you're using in this way, and then /mcp, and then we are gonna connect to this server. We have a tab called the tools. This is literally all you need to debug and to test your MCP server. So now we need to go to tools and list the tools to see all the tools that we have. So we have all the tools that we've talked about, which is product analyst, research engineer, software architect, technical lead, senior developer, QA engineer for testing, DevOps engineer, and this tool for documentation. And we have the orchestrator, team status, export project files, reset project, and eventually get project summary. Orchestrator is the core tool that you are going to interact with, because Orchestrator can map and can plan how these tools are going to collaborate to each other. And for that reason, you are going to pass your message, or you are going to paste your message or your request in this box right here. So for testing, I'm going to use this prompt, which says build e-commerce API with the following requirements. And these are the requirements. I will just paste this prompt in this box, and then let's run this tool, and then we can see orchestrator analyzing request. As I told you, first message goes to the orchestrator to plan. So step 1, executing product analyst. Okay, so it is just following the flow that we've talked about. First, we move from the orchestrator to the product analyst, and then to executing research engineer. And then okay, so it's working. Step number 3, executing software architect. All the steps are done, and we have this 200 OC, which means that everything is fine. Now, to export your files, all you need is just to go to export project files and then run this tool. We have success, and this is the output results. We have project export completed, and this is the export date, output directory, which is the root directory of our project, and project name, shop API, core functionality, product catalog management, shopping cart functionalities, and order processing system. So it is just breaking down the whole project in the best practices. So we have the folder structure, source, tests, docs, config, scripts, readme.md, or the markdown of project overview, and literally we have everything we need. So let's move to the redirectory. So we have this new folder called the generated project, and we have the generated script for this API with the functions and with the classes, class product service, user service, and everything, I guess. And we have docs, which has all the documentation needed for this project. Okay, we have the deployment guide with Docker file, and that's amazing. So it gives us an overview about how to deploy this to Docker image or Docker container. So multi-stage build with all the needed scripts to deploy these APIs. So it is just end-to-end process